schnell geht es?
Muss man mal ausprobieren. Eigentlich sollte es schnell gehen, weil die auf dem Desktop liegt.
Okay.
Ich würde halt nur gerne den Presenter ausprobieren, ob der funktioniert. Nee, dann warte ich lieber.
Ja. Labrīt. Good morning, dear ladies and gentlemen. As the Executive Director of the Baltisch-German University Liaison Office, I would like to welcome you today to the guest lecture by Dr. Mārtina Kahes from the Drēzdenes University of Technology. And unfortunately, Mr. Jānis Konrads from the company Trauma Simulator couldn't join us today, but I hope you will enjoy this event also with the lecture of Dr. Kache. But before he starts his guest lecture, I would like to introduce him to you. Mārtina Kahes studied at the Drēzdenes University of Technology, Mechanical Engineering with specialization in rail vehicle engineering. After receiving his engineering degree, he continued at the university as a PhD student and worked as a lecturer at the chair of rail vehicle engineering. In 2014, Mr. Kache received a doctor's degree for a PhD thesis on different configuration of hybrid drivetrains for diesel rail cars. Today he works as a postdoc and senior lecturer at the Drēzdenes University of Technology and is one of the two initiators of the Virturo teaching project. I'm glad that Dr. Kache came to Riga, and now the floor is yours. Please.
Thank you. Labdien, I guess is the word here. Hello and welcome. I'm glad you managed to come, and I would like to seize the opportunity to thank you for the invitation and for being given the possibility to present our teaching project Virturo. As has been said before, it's a teaching project. It's not about research, but about teaching. Part of the credit of the project is due to my colleague, Karim Ben Abdella, who cannot be here today, but he is therefore appearing on the slides as well. So, let's take a look at the agenda. I would like to start with telling you about the background of the project, to give you a better understanding of the motivation, why we started this project and what we wanted to achieve by this project. I would then like to turn to the genesis of the project and outline the milestones that we have managed so far. And later on, I would like to discuss some of the Virturo sub-projects more closely, and I would like to conclude my presentation with outlining the prospects of the project as we see it today. Before we start, I would be interested in your background. Are you students? Are you engineers? Please tell me.
So also these students, some of them, some of academic staff, research staff, we are more of them, more from mechanical faculty and transport institutes, particularly for railway division. Your area is very close for us. We are very interested in your lesson.
Okay, thank you. All right. Let's start with the background of the project. If you want to become a railway engineer at TU Dresden, you need to pass a two-phase curriculum. The curriculum itself is unitized according to Bologna standards, And however, there are two phases that you have to pass. The first phase of the curriculum is covered by the Faculty of Mechanical Engineering, where you would study all the basic courses like mathematics, engineering, mechanics, thermodynamics, fluid dynamics, and so on, you name it. And after you have passed this first phase, the teaching shifts to the Faculty of Transport and Traffic Sciences. And this faculty is host of the Institute of Railway Vehicles and Railway Technology. And our chair of Rail Vehicle Engineering is part of this institute, as well as the chair of Electric Railways. And what we offer students is a range of advanced courses, including traction mechanics, diesel traction technology, railway running gears, braking technology, rail vehicle structures, light rail vehicle technology, and electric railways. After completing the second phase of the curriculum, it's time to do the diploma thesis or the master thesis, just as students choose. We are one of the last universities in Germany where you can do a diploma thesis instead of a master thesis. But as I said, the curriculum is unitized according to Bologna standards nonetheless. That's basically what we do. I'm a senior lecturer at the chair of Rail Vehicle Engineering. My boss is Professor Löffler. He's the holder of the chair. And yeah, you can see him on the left picture, actually, with some of our students during an excursion to a workshop. How attractive is it to study rail vehicle engineering in Dresden? I've brought you some figures. In November 2019, there were about 3,703 students studying mechanical engineering at TU Dresden. Of these students, about 13% have chosen to study road and rail vehicle engineering. That's 489 students. That's not bad. But the problem is that they have to choose between road and rail vehicle engineering. So what would be your guess? How many students will choose rail vehicle engineering instead of road vehicle engineering? Have a guess? 1%? 3%? Actually, it's 32 students, which is nearly 1% of all the students studying mechanical engineering. This is not quite much. Yeah, we need to persuade more students to study rail vehicle engineering instead of road vehicle engineering. These numbers show you our supply, and let's now compare it with the actual demand. There's a new survey of the German Association of Railway Engineers. They have started or completed this survey last year, and they pointed out that there's a demand for 33,000 railway engineers in the railway industry until 2030. Because people grow older, there will be many retired engineers by then. And so we need to educate or teach or to train more of them to become more young people to become railway engineers. So the goal would be to train about 3,000 railway engineers per year. It's clear that not all of these 3,000 railway engineers are actually rail vehicle engineers. We also need signaling experts and infrastructure experts. But even if there are only 300 to be trained each year, there's quite a discrepancy between what we can supply and the demand. So we had to come up with an idea to make studying rail vehicle engineering more attractive, and this is when the tool was born. Before I will tell you about the project itself, I will sum up the key points for choosing rail vehicle engineering as a field of study, as we have discovered them. There are 5 aspects that students might take into consideration when choosing their field of study. The first is the perspectives after earning the degree. I think you all can agree on that. The question is, where can I work? What tasks will my works comprise? What are the wages? Between how many employers will I have to choose, or can I choose? Where will I work in terms of cities or regions in the country? A lot of our students come from Saxony, and they pretty much like to stay in Saxony, so it's very important for them that they find something in the vicinity of Dresden. The second aspect that is quite important is motivation. Some of our students are railway enthusiasts, but not all of them. Some of them are attracted to technology itself, and they have realized that railway technology is actually quite an interesting field to work in. Some of them want to help save the climate, because railways are obviously a very green means of transport, very environment friendly, so this is also a part of the motivation of some of our students. And some of our students have parents who actually work in the railway industry, and who could convince them that it's a good idea to come to us and to work within the industry. The third aspect to be taken into consideration are the study conditions, meaning what kind of laboratories can we offer the students, what kind of software can we offer our students, what are the contents of our lectures, are they attractive, are they up to date, how many students are supervised by one professor or lecturer. This is also quite an interesting and an important issue, because most of the students don't want to go to a specialization where you are one of 100 students being lectured or being supervised by one professor. So this is the more exclusive it is, the better it is. That's one of our strong points, because we don't have so many students, so there's plenty of time for each of our students to supervise him or her. And the fourth aspect is the visibility of the chair of rail vehicle engineering, because we face the problem that we aim at students studying mechanical engineering, but as I've told you before, our chair is within the Faculty of Transport and Traffic Sciences. So we need to draw their attention to us rather than to other chairs within the Faculty of Mechanical Engineering. And the last point, which is quite important, is actually the image of the railway industry. So we have to ask ourselves, what is our image, and what can we do to change the image, if this is possible? To clarify this, or to undermine this, I have prepared 2 slides. One shows how we are, as rail vehicle engineers, see our industry. We see that there are a lot of stakeholders, not only Deutsche Bahn, but also different train operating companies, train manufacturing companies, maintenance companies, and so on. We see that this is a very familiar, a very small industry. Actually, it's actually like a family. You will always meet the same people at different conferences. And we see that it's modern nowadays, that there are a lot of modern vehicles, a lot of interesting vehicles. We see there is not only the manufacturing of trains, but also the maintenance of rail vehicles. We see that there's high-speed trains, goods trains, all sorts of different and specialized vehicles. And we see that there are a lot of engineering challenges that have to be met, and that it's a very interesting topic to deal with. So let's see how most of the mechanical engineering students see our industry. The first problem in Germany, at least, is that they always associate us with Deutsche Bahn. The relationship between the Germans and their railway company is quite complicated. I don't know if you know this. You can say the Swiss, they love their trains, and the Germans, they love to hate their trains, because Deutsche Bahn is not always performing as well as it should. So there are some issues with reliability, and they are not so highly regarded by many young Germans. So it's better for us to differentiate between Deutsche Bahn and us. Of course, we embrace the cooperation with Deutsche Bahn when it comes to research, but when it comes to advertising students, it's better to be separated. The other issue is that railway engineers are regarded as freaks in a way. They are supposed to be people who have to grab a camera as soon as they watch a locomotive. I don't have any problems with that, but that's the image we have to deal with. Some of them are model railway enthusiasts as well, and this is quite a strange hobby for outsiders. For insiders, it's quite interesting, but for outsiders, it's a bit odd. The railway industry is by parts of the students regarded as a technology from the last century. There are still some steam trains running in Germany. A lot of them have taken these trains with their grandparents when they were young, and this is their experience so far with railways. It's considered to be quite rough, simple technology, not very sophisticated, it's always associated with quite old vehicles that are outdated. So we have to to take countermeasures to counter these cliches, because they are at least most of them are not true, and so we had to come up with an idea, with a fresh idea, to improve the image of the industry and of our field of study. Before we get to the tour, I would like to compare what our colleagues of the chair for automobile technology, what they do, what they can offer the students. They offer a practical training for future automobile engineers, where they go to the Lausitzring, which is a car racing facility, and there they are given quite nice cars where the students can actually drive under interesting conditions, and this is hugely supported by the automobile industry. It's one of the highlights of their study. It's quite fascinating, we have to admit. And it's hard for us to compete with this kind of practical training. Our idea was to create our own vehicle. Railway vehicles are, of course, quite huge. So we thought to ourselves, what we can do is to create a virtual vehicle that you can see through virtual reality glasses, And this is not only a training object, but also it could be a demonstration object. It could be an identification offer for our students, and it could be something to improve the public image of our field of study. Speaking of training objects, we wanted to enable our students to do self-guided learning, that they choose what they want to learn and what they want to, in which fields of study they want to improve their knowledge and their skills. We wanted them to cope with complex tasks that are far beyond the 90 minutes that we have in lectures. This is far too little, the time. We wanted to enable them to work on this project across the semesters that they do, that they start in the 5th semester and work at the Verturo project throughout their advanced course time. We wanted them to get each other to know better, to work in inter-year working groups, and we wanted to improve the interdisciplinarity of the learning, so that they can actually connect the different knowledges that they have earned in their basic courses. After all, we wanted to create a playground, basically, for our future engineers, where they can test things, where they can try things out, where they can make mistakes that they are not supposed to make after their studies. And we wanted to use the Verturo vehicle as a mean to generate technical representation with free licenses, which is better than to use representations or illustrations that come from the industry, because they are always connected with others' rights. We wanted to enable our engineers to analyze certain engineering solutions, for example, within the running gears. We wanted to enable them to look at the locomotive at varying levels of detail. And we wanted to achieve a comparison of different design solutions, because when you make an excursion to a workshop, you have to deal with what kinds of vehicles are there, and you cannot exactly choose which solutions you want to see. And having a virtual vehicle, you can switch between different solutions. That's the idea behind it. And we wanted to use the Verturo locomotive to illustrate physical interrelationships. I'd now like to turn to the third point, the identification offer. We wanted the students to create their own vehicle. We didn't want them to reproduce an existing locomotive, but to create their own, so that they can identify with it and can say afterwards, look, this and that on the running gear, on the framework. This was done by me. I have calculated and engineered it. And we wanted to enable them to experience their self-efficacy, which is supported by the virtual reality. It's quite an interesting point when our students, after they have constructed, after they have designed parts or assemblies, when we've put this into the virtual reality, and when they take the glasses the first time and look at their work, it's quite astonishing for them. We aimed at modernizing our public image. with help of Virtuo, and hoped to enhance the attractivity of our courses with it. And it should be an emphasis on our independence, because this is not a real locomotive. It's not a locomotive that is run by Deutsche Bahn or any other railway operator. It's our own, and yeah, we try to create some kind of flagship that is associated with our chair of rail vehicle engineering. Let's now take a closer look on the genesis of the project. What did we do until we finally incorporate the locomotive into the virtual reality? The first step was to contact a student designer. And at TU Dresden you can also study industrial design. And we contacted the student design agency, which is called August. And we found a designer whom we trusted this project with. And we asked her to do 3 different concepts of a locomotive. The first locomotive should be, or should feature flowing forms. It should be very, yeah, it should be round. It should convey a positive image. It should be, yeah, it should be welcoming in a way. The second concept should be a locomotive with edge shapes, with quite a powerful appearance. And the third concept was a design that was based on the idea to remember forms that have already been used. We supplied her with photographs of French locomotives from the 60s and 70s. They are called Kache. I don't know if some of you might know these. Quite interesting locomotives. And it should be some kind of retro design. It should be kind of aggressive and powerful as well. And yeah, the 3 drafts were put on a vote by us, and we let our students and the alumni vote which design we should take. And this is the outcome of the first phase of the project. You see 3 very different kinds of locomotives here. So yeah, I don't know which one would have been your favorite.
2 and 3.
2 and 3. This one or this one?
No, that.
Ah, okay, yeah. Anyone else?
3.
So this would be 3. This is 1. This one. Okay. Yeah. Okay. Most of our students agreed, actually. You can see the results. The approval rate of the concept 3 were 23.0%. The approval rate of concept 2 was 28.4%, and the approval rate of the first concept was 48.6%. It's quite unusual to put design on a vote. All the professional designers we spoke to, they all said, "Oh, don't do this ever again. You don't put design to a vote. You just have your concept and you do it." But we wanted our students to identify themselves with the locomotive, so we obviously had to take their opinion into consideration. My favorite would have been the loco on the right, but I'm glad as well that we chose the other concept. So this was the basis of our concept, and the next step was to model this in a CAD environment, a computer-aided design environment. And this was not the last shape of the body, because we had to take into consideration the construction gauge of the locomotive. We put a construction gauge around it and clipped all the parts that collided with the construction gauge. You can see this here as well. And after that, we had finally reached the last or the final shape of our locomotive. In addition to that, my colleague Karim Benabdella built a model locomotive in scale 1 that we can take with us to conferences or fairs and to days when our field of profession is presented to students, so that there's something there to see, to look at, not to touch. But yeah, it's quite a nice thing to have to go around with. As I have taken the plane yesterday, I couldn't take it with me. So, and we extended the CAD model of the loco as well. This is what I called a playground for our soon-to-be real vehicle engineers. We generated some of the parts as placeholder constructions, as you can see here. The mainframe, the bogies. This is just something that had to be there, obviously, but the task of our students was to replace these constructions with their own constructions. And we also added some of the containers here. This is for braking equipment. This is for power electronics. This is for the cooling and so on. It's just that we defined the construction spaces so that the students knew how much space they have for the assemblies. I would like to present some milestones that we managed during the last 5 years, 4.5 years. This is my colleague Karim Benabdella, and we presented the project at a conference in Dresden in 2015, soon after the initiation of the project, because we wanted people from the industry to know about the project and to advertise it in a way that they could support us if they were willing to. The next important step was 2018, when we did our first steps in the VR environment. You can see the HTC Vive component here before my eyes, and the next step was to participate in a workshop which was called hands-on virtual reality and augmented reality learning. This was a workshop with an emphasis on learning, and we had great support there, very enthusiastic people, and they helped us build the prototype of a smartphone app that enables students to look at the Verturo and to explore the Verturo. It's a prototype by now, and we are willing to develop it further, but the first step was taken there. You actually, all you need is a sheet of paper with our logo on it, and if the camera detects the logo, it will the Verturo locomotive will fade in, and you can move the telephone and move around the locomotive. So, as I said, it's the first step, and we intend to develop this further. And another highlight last year was the official opening of our Verturo VR lab. I put this in high commas because our lab actually consists of this device and a very powerful computer. So and a large screen so that you can see what the person who wears the glasses can see. That's our lab, but it's a huge step forward because this offers our students the possibility to go into the virtual reality as soon as they want to. Okay, there are of course some milestones that are due to our students. It's not only that Karim and me are working on the project, but there are a lot of students too who have engaged in the project. And the first project or the first milestone was that one of our students, Tobias Schmidt, he developed a VR scene, meaning that he constructed some kind of yard where the Verturo locomotive stands. And there are 3 different planes or levels at which you can wander around and at which you can explore the locomotive. I will turn to this one later on. Another interesting sub-project was the creation of our own bogie design. This is a teamwork because we started with the actual wheel sets and with calculating the diameter of the wheel sets, and later on the bogie framework or the bogie frame was designed, and the traction motors and the gears and so on. It's still work in progress, and then we had two students who created the vehicle body structure, which is quite a difficult task because it's very, very complex, and it's also a task that is not completed because it needs to be evaluated, and there are still some changes that have to be done. But the first step is taken, and it has a shape that is quite convenient. One of our students developed the driver's cap of the locomotive. He had the driver's desk finished by another student, and his task was to complete it, to develop an entire driver's cap around it. And another student who fancies CFD modeling, which is not part of our curriculum, he took the task to model the locomotive so that a CFD calculation was possible. It's quite difficult to do this. And another student modeled a cooling unit, which is now also incorporated in the locomotive. And we have already started to color the different parts of the cooling unit so that students can better understand where the cold water gets in and the hot water gets out. Where the hot water gets in and the cool water gets out. So it wouldn't be the cooling unit if it was different. All right. So after seeing these milestones, I would like to turn to some projects to discuss them in detail. The first is the VR scene. The goals were to transfer the CAD models into the virtual reality environment. And to cluster the assembly according to their functions so that we can fade out and fade in different parts of the locomotive to give the students a better understanding of the structure of the locomotive. And the third goal was that students should be enabled to explore the locomotive on 3 different levels. One is the ground level, that you stand in front of the locomotive and you can look around and see the locomotive as if it was real. The second level would be the driver's cap and the engine room. You can start at one driver's cab and cross the locomotive through the engine room to the next driver's cab. And the third level was the working pit, where you can go beneath the locomotive, see the bogies from beneath. I have some pictures with me. I hope you can see this in the last rows as well. This is in the working pit below the locomotive, where you can see how the bogies are connected to the locomotive frame, and yeah, you can explore the construction of the bogies from beneath. This is the driving cab with a view to the engine room. And this is the driving cab itself, with the seat and the driver's desk. And this is again our cooling unit within the engine room. If you would pass this door here, you can see it already. You will. The next thing you see in the virtual reality is the cooling unit. Another interesting. Before I get to the other project, I would like to show you the process, how we managed to take the parts from CAD software into the virtual reality. We use SolidWorks as our 3D CAD software, and we need the purpose of the 3D CAD software is obviously the construction of parts and assemblies, and we use a game engine for the VR environment, which is called Unity. I don't know if any of you knows this. There are some gamers among you, possibly. The problem is that it's not so easy to transfer the models from SolidWorks to Unity. This would be the direct way, but as we have seen, this is not possible. We need to go a way around and to use Blender, which is a 3D computer graphics software tool set, in order to migrate the models of the SolidWorks models, and after migrating them, after transforming them, we can put them into the VR scene. You have to keep in mind we are mechanical engineers. We are not software engineers, so there might be a better way, and we are keen to know different ways, but this is our way, and it works. So, all right. The next sub-project I would like to talk about is the bogie frame. We had one student who was very keen to calculating and to go into detail concerning the construction and the structure of the bogie frame. So his first task was the basic construction and modeling. His second task was to analyze the load cases of such a bogie. As some of you are railway engineers, you might know how complicated and how difficult this is, because there are a lot of forces and a lot of forces working on this bogie frame that you have to keep in mind. Afterwards, he did a proof of strength by means of finite element method program, and he even went more into details and did a mathematical verification of the welding joints. This was a student project, about 500 hours, and he was afterwards regarded with credit points for this. So it was part of his curriculum. Okay, the next sub-project that is worth taking a look at is the car body structure. We've seen this before. Yeah, the initial goal was the design and the rough layout of the car body structure. We know that this is not the last version of it. There will have to be changes because yeah, there's not enough space for the traction generator, for example, as we have seen now, because we have a traction generator. Meanwhile, someone has modeled the traction generator, and yeah, we see that there's some work to do so that it fits properly into the framework. Some other firmer steps are the optimization of the construction, the proof of strength using FEM again, a development of crash structures that ought to be here and here. This is not a crash-worthy body frame by now, but it needs to be according to the standards. The integration of drawbars and buffers, and yeah, that's about it. That's the next steps. As soon as there's another student who likes to do some work about the car body structure. These two works actually they went parallel. The car body structure and the driver's cap, and it was quite instructive for our students to see that this is very complex, that the one designing the driver's cap had to consult the one designing the car body structure and the other way around. So they had to work closely together, which was a new experience for them. And they had to do a lot of changes, which was very unnerving for them, I guess. But this is how you learn, I guess. And this is something that you will face in the industry as well, that you have to talk to your colleagues, and this is always a teamwork, and that you have to define the interfaces and so on. So yeah, the goal of Mr. Wang was to design and model such a driver's cab, which is he had to model the driver's seat, an auxiliary seat that you can see over there for another person to ride on the cab. The cab rear wall with yeah, cupboards and yeah, places to store things. The windows, the side windows of the locomotive had to be modeled. The whole kinematics of the doors and of the windows had to be examined so that you can actually open and close them in the way they should. There should be no collisions, and all the doors should be opened at least 90 degrees. So this might sound a bit trivial, but it isn't. If you take a closer look at the construction. The auxiliary controller panel, which is this one here, that the drivers can use when they have to observe the train. So they can use this auxiliary panel to power and brake the train or the locomotive. And the engine room door also had to be constructed, and it had to be a door that enables the driver to flee in case of a danger. So it's not a simple construction. It is a construction that is kind of different. It's not only the door. So, and he also had to model the paneling elements around the driver's desk so that there will be no gaps between the locomotive and the driver's desk. All right. Yeah, to give you an overview or an outline of all the projects that are in progress now, I have prepared this slide. We have one student working on adding animations to the VR scene. We have someone constructing and modeling the bogie-mounted braking equipment. We have someone constructing and modeling the sending equipment of the locomotive. We have someone dimensioning and modeling electrical machines, the traction machines, as well as the traction generator. And yeah, as I've showed you before, there's someone who estimates the aerodynamic drag by means of a CFD simulation. He has now managed to get the system to run, but it takes time to optimize the calculation. And we have had someone constructing crash-worthy side buffers. We had someone modeling the draw gears, and yeah, this is it concerning the Virtuo sub-projects. And now I would like to conclude my presentations with showing you some prospects of the project as we see them. The first goal we have is to create an environment where our students are enabled to assemble, for example, a bogie. So we would provide, we would extend the VR scene and create something of a working environment, of a working plan environment, and define the component interdependencies so that they are so that they have some kind of feedback if they have assembled wrong. We would have to define an assembly process, and we would have to implement a pick and examine functions so that you can, within the virtual reality, pick some parts and look at them from different angles and then put them somewhere and release them again. Another goal that we have is that we would like to animate the VR scene further. There's until now there's only one animation. If we press a button, there will be an exhaust fuel pile here, which is just for fun, and there's nothing to teach there. But we would like to enable students to open and close windows and doors, and to move the levers in order to move the locomotive some meters. We would like to make the vehicle run and the wheel sets to turn, which is again quite simple if you hear it, but it's harder to implement this in the VR scene. Open and closing of windows, I've already said this, and make the control levers move. And that's another goal that we have. We would like our student who does the CFD calculation, we would like to use his results in order to add streamlines to illustrate the airflow around the vehicle, so that you can actually be inside a kind of a wind channel to see how the streamlines flow around. Another goal that we have for the future is to derive versions of the vehicle. We can use our Virtuo engine as a platform and derive, for example, a driving trailer, which would enable us to do some interior design as well, and to create an entire interior of a passenger wagon. We could turn it into an electric locomotive, and we could as well take it into a dual power locomotive. Dual power locomotives are quite are quite fancy today. They are quite modern. A lot of manufacturers nowadays offer dual power locomotives so as not to use the diesel engine if there's a catenary above your vehicle. This would help us study different types of vehicle concepts. It would help us to give the students a better understanding of the modularity of vehicle designs, and it would help us also to improve their understanding for issues of mass and construction space management, because our mass is limited, and if we have a dual power locomotive, we need to have a transformer, we need to have the diesel engine, we need to have a diesel tank, and so it will build up very quickly, and it's a very tricky task to combine all these components to have a locomotive that actually works. Okay, Paldis, Paljuso Interesi, thank you for coming here, and I'm happy to answer any questions.
Can you tell us, is it possible to implement this software for educational procedure, not only for students but also for personnel in workshops, just to train them?
It would, it would be possible. Yeah, it's not what we intend to do, but the possibility is there, and we know that there are some projects who will actually try to teach the personnel in workshops. Yeah.
And the second question, you mentioned that you try to derive or to borrow some existing models. So, as I understood, it's possible to make some kind of library for existing models, yes, and to put in your software also.
Yeah.
And in real life, is it possible to get some existing 3D models from producers? I don't know, Siemens or Skoda, for example.
It's a bit complicated. It's not what we intend to do because it's their know-how. But for example, MTU, the manufacturer of diesel engines, they supplied us with a model of the diesel engine. It's just the case. There's nothing in it, so you cannot build the motor. But we have the outer shape of the motor, and that's a first step. And we have a colleague who just offered us to support us with a gear model and a coupling, for example, and he would do this for free. Yeah. Yes.
I would like to know how did you analyze the engineering solution for the demonstration of your object?
Sorry, I didn't quite understand the question.
I would like to know the engineering solution, like you have analyzed, right? You said in your motivation of the slides. Like what techniques did you use to analyze this demonstration of object?
So let's see. Let's take a look at the slide you are referring to.
Yes, this one. In the demonstration of the object, there is analysis of engineering solutions.
Okay. Yeah, this is actually meant that we intend to use the Verturo to analyze the engineering solutions. For example, if you want to link the bogies to the locomotive frame, you have different options. You can use traction rods, or you can use pivots. And we would like the model to incorporate both, some versions of it, in order to enable our students to look and see and to realize the different possibilities they have. That's what I meant with this point.
I have a question actually I'm curious about. What are your methods, or what is the other professors' attitude to this kind of thing, that virtual reality in education, and how they are ready to start to use it in their daily lessons or projects?
Yeah, actually, it's a question of generations. My boss is quite old, and he is very conventional. I don't say bad, but conventional lectures, and he's willing to do this, but we have to support him, obviously, and we already have taken over some part of his lectures to show the students the model, where it fits in. So.
Because I'm really proud of your job, it's really cool. Like, I would love to have, for example, it in my university, for example. So it's pretty good. Keep doing. Second question is, what about foreign students at your university? Do you allow them? I saw some surveys. Do you allow them to be part of this project?
Yeah. Students are invited to work within the project. For now, they cannot get credit points because it's very complicated to incorporate such a project into the curriculum. It's you have to talk to lawyers and to keep a certain process of integrating it. But they can come to us, and they during their curriculum they have to do one or two theses. It's not the master's thesis, but it's comparable in terms of the working load and the amount of pages they need to hand in, and they can make this their study project, as some of the students have done that I've shown here in the sub projects.
Yeah, thank you. Good luck.
Thanks. He was first.
Do you think in the future the students, engineers, and designers could work together in virtual reality?
I hope so. That would be my dream, and that's the point why we consider deriving a driving trailer, because it would be very interesting to work with design students to create a new environment and a progressive environment, not the environments that we know today, but to go a step further and imagine the environment of a.
Is there already such software?
Pardon?
Is there already such software that supports groups to work and design together?
There might be, but we are not using it yet. So they would have to work in, nowadays they would have to work with SolidWorks.
In VR?
No, they would have to create their models in SolidWorks, and we would have to transform and export the files. But as I said, we are open to new suggestions how we can change the process to make it easier and
Have you heard about the Oculus Quest?
Yes. But we use the HTC Vive.
It's outdated.
it might be, but we are very glad to have it. And I would not. Maybe we will change in the future, but for now we're happy to have it. Okay, thanks. Mm-hmm.
Thank you very much for your exciting presentation. And the question is, are you collaborating with the Fraunhofer Institute in Germany related with virtual and augmented reality issues?
No, not yet. It's just a teaching project, and it's a free project, and we are happy to be supported, but we need to keep this free and open source in a way. We don't want to have any kind of models in there that we could not show freely around.
Because they are very deeply involved in exactly this field, and already 10 years ago I saw similar assembling tasks in Magdeburg chapter, also in Darmstadt.
Yeah, I know, but it's always a question of funding. This is kind of a hobby project for Karim and me, And
this is clear.
The main requirement to make this model is technical, aesthetical, or design review. The main driver to make this model from your side.
Nowadays, it's the engineering part of the process. We started with design process.
So the driver is design. So you made design, and then you develop this model, put into technical solutions. Yes.
Yeah.
But the first step is design.
Yeah, the first step was to design because we wanted to have our own locomotive and we wanted it to have a specific shape and not just, it should be, it was supposed to be special. And now our students have to cope with what the designers have given them.
For example, if a future customer wants to get a locomotive with a great directive effort, you have to detect is it will be a 4 or 6 axle locomotive on design stage. You can also suggest it.
Yeah.
Is there a plan to build this locomotive real? Maybe a part of it?
No. It's just a playground for our students. Okay. Thank you again for your questions.
Okay, thank you. If there are no more questions in the moment, thank you very much for coming to Riga and giving such an exciting presentation. I would like to thank you all for coming this morning. And I would like to say that our office is not only organizing this kind of scientific events in different fields, but we are also supporting scientific projects in cooperation with Germany. So I see that many of you thought that this is an exciting project. So if you maybe are interested for some cooperation, then there is some support for starting cooperation with Germany. And today you have also a possibility to talk to Dr. Kache. Maybe he is interested also for cooperation, or maybe he can recommend some of his colleagues. And now we can continue our discussions in some more informal way with some cup of coffee. And if you have still some questions for Dr. Kache, so you are welcome. Thank you.
Thank you.